Hey everyone and welcome to this session on trigonometry. Especially in this session we are going to talk about trigonometric identities, the three identities that you have already studied. We are going to apply those in problems and see ample of questions in this session. So I hope all of you are excited alongside me, and let us try to understand how many questions were asked from 2018 to 2024 from this particular chapter, that is trigonometric identities. So if you see, two questions of 1 mark back to back were asked in year 2023 and 24. One marker was asked in 2018, 19 and 20, and also 4 marker is a very important because almost one question of 4 marks is asked every year. In 2023, 2024, even in 2020 it was asked. So if you see the overall weightage, it is around 5 to 7 marks is what you can say. So again, in this particular year you can expect one MCQ and one long question of 3 marks or 4 marks from this particular chapter, sure shot. So firstly, we need to know all the three trigonometric identities. Also, if you want to take a screenshot of this gives you a clear idea of how many questions of how many marks were actually asked previously. You can see here these yellow bars clearly tell you that a 4 marker is a very important question. Almost every year it is asked, and the 3 marker is also important along with 2 1 markers which were asked previously in 2023 and 2024. So before starting with the actual problems, let us recall all the three identities, isn't it? We know that sine square theta plus cos square theta is equal to 1. That is the first identity. Then we know that 1 plus tan square theta is equal to sec square theta. That is the second identity. And the third identity is 1 plus cot square theta is equal to cosec square theta, right? So cosec square theta. So these are the three identities, very important identities for this particular chapter. And we are going to use these identities to solve the problems, also to prove them. So let us see. Okay, so it is prove that under root of sec square theta plus cosec square theta is equal to tan theta plus cot theta. So whenever they tell us to prove something, we'll always start with the LHS or with the RHS. Here, it's better we start with the LHS, right? So I'm beginning with the proof. What is the LHS? The LHS is under root sec square theta plus cosec square theta, right? Okay. Now we know that 1 plus tan square theta is sec square theta. So instead of sec square theta, can I write down 1 plus tan square theta? Yes. We know that 1 plus cot square theta is equal to cosec square theta. Just understand this. So instead of cosec square theta, can I write down 1 plus cot square theta? Yes. So let us do that. This can be further written as sec square theta is 1 plus tan square theta. Cosec square theta is 1 plus cot square theta, isn't it? Now understand. Now can I write it as under root, this is tan square theta plus this is cot square theta plus 1 plus 1. Can I write down 1 plus 1 as 2? Now we know that tan and cot are reciprocal of each other, isn't it? We know that tan multiplied by cot is 1. So this is 2 into 1, right? So can I write down 1 as tan into cot? Yes, I can do that. Okay, so this can be further written as under root tan square theta plus cot square theta plus 2 tan theta cot theta, right? Now can I say, I can consider this as a square plus this can be written as b square plus this is 2 into a into b, right? Tan theta is a and cot theta is b. So further, this becomes under root tan theta plus cot theta the whole square. Square root gets cancelled and ultimately you get tan theta into cot theta plus cot theta, not into, plus cot theta. And can I say this is my RHS? Yes. So can I say I have proved that LHS is equal to RHS? Yes. So we can say LHS is equal to the RHS, hence proved, correct? Perfect. Let's continue. Okay. So we are supposed to prove that 1 plus cot theta minus cosec theta into 1 plus tan theta plus sec theta is equal to 2. Again, this is a prove that question. It was asked for 4 marks, but trust me, it is very, very simple. All we do is we start with the LHS. So let's begin with the proof. And what is the LHS? The LHS is 1 plus cot plus cosec. So 1 plus cot theta minus cosec theta into 1 plus tan theta plus sec theta. Now can I write down cot theta as cos by sine? So this becomes 1 plus cos theta by sine theta minus cosec can be written as 1 by sine theta because sine and cosec are reciprocal of each other. So this is what I get further. In the other bracket, apply the same logic. We know that tan theta can be written as sine theta by cos theta and sec theta can be written as 1 by cos theta. So this further becomes 1 plus cos theta minus 1 by sin theta, cos theta minus 1. This is the common denominator by sin theta, and this becomes 1 plus 1 plus sin theta or sin theta plus 1, sin theta plus 1 by cos theta. Correct? Now, if I cross multiply this, understand, just cross multiply here and cross multiply here, I get sin plus cos minus 1 by sin. This is cos plus sin plus 1 by cos. So let us do that. So after cross multiplying, you get sin plus cos minus 1. This becomes sin plus cos minus 1 the whole by sin. Correct? And this becomes sin plus cos plus 1. Sin plus cos plus 1 the whole by cos. Correct? Now understand very carefully. So here sin plus cos, here sin plus cos, here minus 1, here plus 1. So if I consider sin plus cos, if I consider sin theta plus cos theta as A, and if I consider 1 as my B, here I have a format of A minus B, and in the other bracket I have A plus B. What is A minus B into A plus B? A square minus B square. So let us do that. So if I do a square minus b square here, I get sin theta plus cos theta the whole square minus 1 the whole square, the whole divided by sin theta into cos theta. Now we can solve this further. This is a plus b the whole square, so that gives you sin square theta plus cos square theta, right, plus 2 sin theta cos theta, correct, and then minus 1, and this is whole upon sin into cos. Now what is sin square theta plus cos square theta? What is this? This is 1 and this is minus 1. So can I cancel 1 and minus 1? This 1 and this minus 1 will get cancelled. What will remain? 2 sin theta cos theta divided by sin theta cos theta. So this is further equal to 2 sin theta cos theta divided by sin theta cos theta. This will get cancelled, this will get cancelled. The answer that you'll get is 2, which is nothing but your RHS. So we have proved that the LHS and the RHS are equal, and that's it. And we have proved this one. Easy. Okay, let's continue. Now a similar question, it says prove that cosec theta minus sin theta, sec theta minus cos theta, tan theta plus cot theta is 1. See, these look slightly difficult, but trust me, they are very easy, because all you need to do is try to convert them. Try to convert them in sine and cos. Once you try to convert them in sine and cos, it becomes very easy. Okay. So what is the LHS? We start with the LHS, right? So the LHS is cosec theta minus sin theta, then sec theta minus cos theta, and then you have tan theta plus cot theta. Cosec theta can be written as 1 by sin theta, because cosec and sin are reciprocal of each other. This is minus sin theta, correct. Then sec can be written as 1 by cos. This is minus cos theta. Don't change cos, keep it as it is. Keep everything in sin and cos. And this becomes sin by cos, right? Sin theta by cos theta plus cos theta by sin theta. Correct? So if I cross multiply, what will I get? If I cross multiply, I get 1 minus sin square theta by sin theta, correct. Here I get 1 minus cos square theta by cos theta, correct. And here if I cross multiply, sin into sin is sin square theta plus cos into cos is cos square theta whole divided by sin theta into cos theta, right? Now can I say this part is 1? So if I solve this further, and can I say 1 minus sin square theta is cos square theta, and can I say 1 minus cos square theta is sin square theta. So let us put all these results together. So cos square theta by sin theta. So further we get cos square by sin in one bracket into sin square by cos in the other bracket, and then we had 1 by sin theta cos theta. So cos square cos, sin square sin, right? And then sin gets cancelled, cos gets cancelled, and you get 1. And what is 1? 1 is your RHS. So we have successfully proved that the LHS and the RHS are equal. That means we have proved it. Very easy, correct? Okay, let's continue. Okay, now the question says, prove that. Again a very simple question. See, convert everything in sin and cos. Sin a by 1 plus cot minus cos a by 1 plus tan is equal to sin a minus cos a. Just focus on the left hand side. You begin with the left hand side. Ultimately you are going to reach the right hand side. Okay, so we have sin a by 1 plus cot a minus cos a by 1 plus tan a. So this can be written as sin a by 1 plus cot a can be written as cos a by sin a minus this is cos a by tan a can be written as sin a by cos a. Now here you can cross multiply, here also you can cross multiply. So you get sin a by sin a plus cos a by sin a. So you get sin a by sin a plus cos a by sin a plus here cos a by same thing cos a plus sin a by cos a. This goes up, this goes up, this gives you sin square a by sin a plus cos a. Plus, I hope you are concentrating because these are a bit slow questions. Cos a goes up, that gives you cos square a by sin a plus cos a, right? So sin a plus cos a is the common denominator here. So in the numerator we have sin square a minus cos square a. Now what is a square minus b square? That is a plus b and a minus b. So this gives you sin A plus cos A into sin A minus cos A divided by sin A plus cos A. Can I cancel sin A plus cos A? Yes. What will remain? Sin A minus cos A. And that is nothing but your RHS. Right? Because if you see this, only this part is pending here. Rest all is cancelled. That gives you your RHS. So we have proved that your LHS is equal to RHS, and that's it. Okay. Okay, so let us see a new question. It says prove the identity 1 minus tan theta the whole square by 1 minus cot theta the whole square is equal to tan square theta. So if we start with the left hand side for the proof, on the left hand side, what do we have? We have 1 minus tan theta by 1 minus cot theta the whole square. And on the right hand side, we want only tan. So can we convert cot in terms of tan? We know that cot and tan are reciprocal of each other. So can I write this as 1 minus tan theta by 1 minus cot theta can be written as 1 by tan theta the whole square. So can I write this further as 1 minus tan theta by tan theta minus 1. Understand this, I am just taking the LCM here. So this is further equal to 1 minus tan theta by tan theta minus 1 by tan theta. Tan theta minus 1 by tan theta the whole square. I hope you are getting this. Now, if I take the reciprocal here, this is equal to, I'll write down tan theta here, it goes above, tan theta goes up into, I have 1 minus tan theta by, this is tan theta minus 1. Now see, this is A minus B, this is B minus A, correct? This is 1 minus tan, this is tan minus 1. Now A minus B, B minus A. If I have A minus B divided by B minus A, what is the answer to this? If I write it like this, can I write it as A minus B by A minus B and put a minus sign outside, because see, minus into A, minus minus plus B. So the ultimate answer to this is minus 1. I'll give you one more example. If I ask you what is 3 minus 5 by 5 minus 3, this is also going to be minus 1. See, 3 minus 5 is minus 2. 5 minus 3 is 2. The answer is minus 1. What is 10 minus 20 by 20 minus 10? Minus 1. So here, since we have 1 minus tan and tan minus 1, taking this as 1 minus tan. So this is further equal to tan theta into 1 minus tan theta by minus of 1 minus tan theta. 1 minus tan theta gets cancelled, and here we have a whole square if you see, because we have not expanded the bracket, and then ultimately you get minus of tan theta, because this minus sign is there, the whole square, and that is nothing but tan square theta. And what is tan square theta? Tan square theta is your RHS. So definitely we have proved that the LHS is equal to the RHS. I hope you have understood this question. Very easy, very simple, straightforward. Whatever they are asking, just find that out. They wanted tan on the right hand side. We have kept everything in tan, kept on solving, and we got tan square theta at the end. Okay. Now this is the one marker, it's an MCQ, so let us do it quickly. So even if they don't give this in MCQ, how will you solve this? We have 1 plus sine into 1 minus sine. 1 plus sine A into 1 minus sine A. We know that this is as good as A plus B into A minus B, that is A square minus B square. So that is 1 square minus sine A the whole square. That is 1 minus sine square A. And what is 1 minus sine square A? Cos square A, right? That's it. Very easy, very simple, right? Okay. Let's have a look at one more question. It says, prove the following identity. Sine square theta minus 1, 1 plus tan square theta plus 1 is equal to 0. Okay. Now it is very simple, because if you see, almost identities are going to be used here, the basic identities. So how are we going to do that? So let us pick up the left hand side first. Let's begin with the proof. So we have sine square theta minus 1, then we have tan square theta plus 1, and then we have plus 1, right? Now firstly, we already know that 1 plus tan square theta, this is straightforward, right? We know that 1 plus tan square theta is sec square theta. So here I can write down sec square theta, correct? Now understand this. If I see this part, this is sine square theta minus 1. Now let's recall the identity of sine. We know that sine square theta plus cos square theta is 1. So if I shift 1 to the left hand side, can I say sine square minus 1 is equal to, if I shift cos square on the other side, that becomes minus cos square theta. So can I say sine square theta minus 1 is minus cos square theta, correct? Then there is multiplication here, and this is plus 1. Now can I say sec and cos are reciprocal of each other? We know that sec is 1 by cos, or cos is 1 by sec, same thing. So this becomes minus cos square theta into sec is 1 by cos square theta plus 1. Cos square theta gets cancelled. Minus into 1 is minus 1. So this becomes minus 1 plus 1, and that is nothing but 0. And that is your RHS. And if you see, such a simple question was asked in ICSE 2023. So easy. Hardly 4 to 5 steps, and we have proved it. Correct? Okay, let's continue further. Now let us see an MCQ. It says statement 1 is sine square theta plus cos square theta is 1. Statement 2 is cosec square theta plus cot square theta is 1. So which of the statement is valid? That means which identity is correct? See, the first identity we already know, sine square theta plus cos square theta is 1 is true, right? We know that sine square theta plus cos square theta is 1. But what is the relation between cosec and cot? We know that 1 plus cot square is cosec square. So definitely cosec square plus cot square is never 1. Cosec square and cot square is never 1. Cosec square minus cot square is 1. This should have been minus, so this is false. So obviously only statement 1 is true. Easy question. Only identity we needed there, and we have applied that. Right? Now the question says factorize sine cube theta plus cos cube theta, and also prove this part. Okay, let's focus on factorizing sine cube theta plus cos cube theta. Now can I consider sine theta as A and cos theta as B? So this is like my A cube plus B cube, right? So what is A cube plus B cube? A cube plus B cube is A plus B, A square minus AB plus B square. AB or BA, same thing, doesn't matter. So A plus B into A square minus AB plus B square is the expansion of, these are the two factors you can say, of A cube plus B cube. So here A is sine theta, right? So A is sine theta and B is cos theta. So this is A plus B, that is sine plus cos. And then you have A square, that is sine square theta, minus AB, that is sine theta cos theta, plus B square, that is cos square theta. Now already here you have sine square theta plus cos square theta. How much is sine square theta plus cos square theta? That is 1. So can I write this as sine theta plus cos theta into 1 minus sine theta into cos theta. So we have factorized. The factorization part is done. Now let us see what is the second question. Okay, so we are supposed to prove this, that sine cube theta plus cos cube theta by sine theta plus cos theta plus sine theta cos theta is equal to 1. This is what we are supposed to prove. Now, if you see already, we have factorized sine cube theta plus cos cube theta. So let us focus on the LHS. So what is the LHS? The LHS is sine cube theta plus right plus this is your LHS, right? Now this we have already factorized sine cube theta plus cos cube theta. Recall, it was sine plus cos, sine theta plus cos theta into 1 minus sine theta cos theta divided by sine theta plus cos theta and then this part is written here, denominator as it is, and here I have plus sine theta cos theta. So sine theta cos theta gets cancelled. So I get 1 minus sine theta cos theta plus sine theta cos theta. Sine theta cos theta minus sine theta cos theta gets cancelled and you get 1, which is nothing but your RHS. So LHS and RHS are equal and we have verified it. So that's it for trigonometric identities. I hope you have enjoyed the session alongside me. We'll solve ample of problems in the next session as well with a new chapter. Until then, keep learning with me and learn with top scholars. Thank you.